Hi everyone. Already we have completed all the concepts in the heat chapter. So what are the concepts? We have seen few formulas in this chapter. What are the formulas what we have learned in this chapter is that heat energy. What is the formula for heat? Q is equals to ms delta T. This is an important formula while you are solving the problems. And another one is what temperature of mixture is what? M1 T1 plus M2 T2 by M1 plus M2. So these two are the main important formulas for while solving the problems in the heat chapter. So today in this class, let us see some problems, some numericals based on this chapter. Okay. Before going through these problems, let's have a graph telling about mentioning about all the what is the latent heat of fusion, all those things. So here, if you take a graph, you consider a graph, think that this is our heat energy and this is our temperature. Okay, I think you have seen this type of graph. So the important point about this graph is that, think that an ice cube. So here, O to A. Here what is happening? We are giving, increasing the heat energy. At the same time, we are measuring the temperature. So here what we can observe that this part, OA part tells about the solid state. Solid state means what? Ice cube. So when you are giving the heat energy, whatever the heat energy is, the thing that I is that below 0 degrees Celsius, 0 degrees Celsius. So what you are doing? You are heating the ice cube. So ice goes on melting. So this is what solid state. So here, as the temperature goes on rises, once it reaches A, okay, from A to B, what we can observe that though we are giving the heat energy, though we are providing the heat energy, there the temperature is not rising. Temperature became constant, and so this, as I already told you that the whatever the heat energy is there for the ice cube, but until all the ice cube melt, the temperature doesn't change even though we are providing the heat energy. That heat energy is called as what? That heat energy is called as latent heat of fusion. So this part is called as what? Latent heat of fusion. Latent heat of fusion. So here why the temperature is not changing even though we are providing the heat energy, but whatever the heat energy is that is utilized by the object to convert its state from solid to liquid. Okay. So once it reaches here, what we can observe here again it is temperature, though we are providing heat energy, at the same time temperature is rising. So here this part tells about what? Liquid state of the substance. Okay, so that is the reason, as it is a liquid state, what we can observe, temperature, think that it is at 0 degrees Celsius. 0 degrees Celsius. Okay, so here think that it is water. From 0 to what we can observe, it has changed to what? Rise to 100 degrees Celsius, you think it here. So once the water rises temperature to 100 degrees Celsius, what we can observe again, even though we are providing the heat energy, what we can observe that the temperature is not changing. So what we can understand here, what as I already told, the amount of heat energy required its state of change from liquid to gases. So here temperature is not changing means what? The energy is utilized by the object to what? To change its state. That is called as what? That is called as latent heat of vaporization. Latent heat of vaporization. That is the reason temperature is not changing even though we are giving the heat energy. Then what we can observe from D to E, what we can say this part is called as the vapor state. Vapor state. That is the reason we are providing the heat energy, temperature is also changing. So here what we have understood that OA tells about the solid state. That is the reason it is less than minus degrees Celsius, less than 0 degrees Celsius. So what happens as we go on increasing the heat energy, temperature goes on rising, it stops at 0 degrees Celsius. So here what we can say that this point is called as the melting point. Melting point. Okay. Now here, as we are providing heat energy, this part is not changing is what? OA part also about what? Latent heat of vaporization, latent heat of fusion. Okay, latent heat of fusion. So after that, what we can observe from B to C, the temperature is changing. So this part is called as what? It is changing. So here it became what? Completely the solid has converted into liquid. Now here what is happening here? This complete part is about the liquid and this part is about the rise in temperature. Okay. Once it reaches 100 degrees Celsius, so here this A point is called as what we can say this is called as the boiling point. Once the water reaches the boiling point 100 degrees Celsius, even though again we are providing the heat energy, what we can observe, temperature is not changing. Temperature is not changing means what we can say, this CD part tells about what? Latent heat of vaporization. There the heat energy is utilized by the object to change its state from what? From liquid to gases. Here what we can observe again, D to E. D to E part tells about what? Vapor state. Understood? So this is our solid, liquid, vapor, and this part is called as the melting point. This part is called as the boiling point. Okay, A is called as latent heat of fusion, and CD is called as latent heat of vaporization. I hope everyone understood this one. Let's see the problems. Okay, now see the question. What is the question given there? How much energy is observed when 10 grams of ice, 10 grams of ice at 0 degrees Celsius becomes steam at 100 degrees Celsius. So this is the question. What they have asked? They have asked to find the heat energy. Okay, they have asked to find the heat energy. So here what they have given, ice they have given, and what we have to find, steam. This means what? Here ice is converting it into steam. So here what we have to do, first we have to convert ice into water. First stage. So okay, after what we have to do, water, here what we have to do, we have to rise the temperature. It is what? To 0 degrees Celsius we will change. From 0 to 100 degrees Celsius, some amount of heat energy is required. What is the third stage? Water to steam or vapor. So 3 stages are there. So we require that 3 different types of energies. Understood? One sort of energy is required for what? One sort of energy is required for converting the state of change from what? Ice to water. Certain amount of heat energy is required. Then what we require? Again we require certain amount of heat energy to rise the temperature from what? 0 to 100 degrees Celsius. Once it reaches 100 degrees Celsius, again what we require? We require another sort of energy for what? What is that? To convert its state from liquid to vapor. So let's calculate the values here. So here Q1 tells about what? Change of state. Change of state means what? Latent heat of fusion, solid to liquid. So what is the formula for latent heat of fusion? L is equals to Q by M. Here we require Q. So in case what we can bring this M to the left side, Q is equals to L into M. Okay. When I was saying the concept, at that time I told what is the latent heat of fusion of ice? It is 80 calorie per gram. Okay. It is latent heat of fusion of ice is what? 80 calorie per gram. So here what we are doing, we are converting the state from ice to water. What is the formula? Q is equals to L into M. What is latent heat of fusion of ice? 80. What is the mass of the substance given? 10. So 80 into 10 is how much? 800 calories. Q1. Okay. So we have converted from solid to liquid. Next one is what? Change in temperature. So you already know the Q formula, heat energy, MS delta T. Change in temperature means we have to use this formula. So what is the mass of the substance given here? 10. Okay. Then what? Specific heat. What is specific heat of water? It is 1 into change in temperature. Change in temperature means what? Final temperature minus initial temperature. Steam means what? It will get at what degree Celsius? 100 degrees Celsius. From where? 0 degrees. So here what we can write? 100 to 0. Okay. What will get? 10 into 100. Nothing but 1000 calories of heat energy is required. Now next one is Q3. Q3 is what? Once it reaches steam, what we have to do? Boiling point of water. What we have to do? From water to vapor we have to state. Again, latent heat of vaporization. So what is same formula we will be using here? What is latent heat of vaporization? Vaporization of water. It is 540 calories. 540 calories per gram. Okay, 540 calories per gram. So here. So what will write latent heat of water? How much it is? 540 into M. What is mass here? 10. What will you get? 540 means what? 5400 calories. Okay. So here we have got Q1 value 800, Q2 value is what? 1000 calories. So here Q1 800 calories required for what? To convert its state from what? Solid to liquid. Q2 value 1000 means what? To rise the temperature from 0 to 100 degrees Celsius. Q3 value 5400 means what? To change the state from liquid to gases. You add all the values. Therefore, Q total is equal to what? Q1 plus Q2 plus Q3. How much you will get? 800 plus 1000 plus 5400. What will be the answer? So what is that? 5400, 1800, 0027. So it is how much? 7200 calories. So here total amount of heat energy required is how much? 7200 calories. I think everyone understood this problem. Let's go for the next problem. Let's see the next question. What they have given. When 500 calories of heat is supplied for 50 grams of substance, its temperature rises by 15 degrees Celsius. So what they said that 500 calories of energy is required for what? For 50 grams of substance to rise the temperature to 15 degrees Celsius. To 15 degrees Celsius. What is it? How much heat energy is supplied to rise the temperature to 50 degrees Celsius? Now they are asking what? 50 grams of substance is there. So when we are providing 500 calories of energy, its temperature rises to 15 degrees Celsius. Now they are asking what? How much amount of heat energy is required to rise the temperature to 50 degrees Celsius? So here you already know this. You just take it as x here. You do what? You just do the cross multiplication. Let's cross multiply. So what you will get? 500 into 50 is equals to 50 into x. Okay, therefore x is equals to 500 into 50 by 15. Okay, now 5 tens are 5 threes are. So what is that behind x is equals to 5000 by 3. So here 5 ones are 3 ones are 3. 5 minus 3 is 2. 20. 6 threes are 18. Again 2. 6 threes are 18. Again 2. 6 threes are 18. Something like that. So what you will get? X is equals to 1666.6 calories. So here what we came to know that when 500 calories of heat energy is required to change the temperature to 50 degrees Celsius, how much energy is required for 50 degrees to change the temperature to 50 degrees Celsius? We require 1666 around calories of energy is required. Understood? So here comes one graph problem. What is the given? A graph shows the variation in temperature of 1 kg of gold. How much they have given? 1 kg of gold. For that purpose, they have given one graph. So this is the graph given. They have given what? One mass, 1 kg they have given, and they have given the graph. Now what they have asked? From the graph answer the following. Melting point of gold. What is the melting point of gold? Just now a few minutes back I have said this graph. So this part tells about what? This part tells about the solid state. Solid state. Solid. Okay. And this part tells about what? Latent heat of fusion. Yes. And this part tells about what? This tells about the liquid state. Liquid. And this part, CD part tells about latent heat of vaporization. And this part tells about the gases or steam. And this point tells about what? This point tells about melting point. And this part tells about what? Boiling point. Yes? What is the question they have asked? What is the melting point of gold? Melting point. What is the melting point of gold? We can say melting point of gold is how much? 1060 degrees Celsius. Okay, next one. What is the boiling point of gold? Boiling point is not this one. What we have given. So boiling point of gold is how much? 2600 degrees Celsius. Okay. Next, the latent heat of vaporization of gold is 57. So they have given latent heat. Value how much they have given? 1577 kilojoule per kg. Kilojoule per kg. Gram per kg. Okay, kilojoule per kg. This is what they have given. What is the question they are asking? How much amount of heat energy is required? What is the Q value? We already know the formula for latent heat. L is equals to Q by M. Q required, right? So we can write what Q is equals to L into M. What is L value they have given? 1577. What is the mass they have already given? 1 kg. So what is the value? 57 kilojoules of heat energy is required. Now, what is the state of gold between B to C? B to C, as I already told, B to C, what is the state of the gold? It is liquid state. Understood? Very simple one. If you know the graph, it is very easy to find the values here. So here, this part, OA part tells about the solid state, BC part tells about the liquid state, DE part tells about the gases of steam state, and here AB part tells about latent heat of fusion, CD part tells about latent heat of vaporization, and A point tells about the boiling melting point, and C point tells about the melting point. Understood? So here melting point is what? 1060. Boiling point is what? 2600. Latent heat they have given, they have also find the heat. So we have got 1577 kilojoules. Understood? That's the next question. 50 grams of water at 20 degrees Celsius mixed with 15 grams. So here what they have given? 50 grams of water is mixed at 20 degrees Celsius. Water at 20 degrees Celsius is mixed with 50 grams of water at 25 degrees Celsius. Sorry, at T degrees Celsius. T degrees Celsius. If the final temperature is how much they have given? 75 degrees Celsius. So they are asking to find T. So here we observe here the order gives M1 T1, M2 T2, temperature of mixture. So what is the formula you use? Temperature of mixture. T is equals to M1 T1 plus M2 T2 by M1 plus M2. Okay. What is the mass they have given? 50. What is the temperature they have given? 20. Plus what is the mass they have given? M2 50. T2 value they have to find out. T. M1 plus M2. 50 plus 50. What is temperature of mixture they have given? 75. Okay. Now 50 plus 50 is how much? 100. 100 into 75. 100 into 75 is equals to 5 2s are 10. 00. 1000 plus 50 T. Okay. Now 7500. 7500 is equals to 1000 plus 50 T. So you bring this 1000 to the left side. What do you get? 50 T is equals to 7500 minus 700 minus 1000. So what do you get? 50 is equals to 75 minus 1000 how much? 6500. T is equal to 6500 by 50. 0 0 gets cancelled. 5 ones are 5 3s are. So what will get? T is equal to 130 degrees Celsius. Okay. Understood. So what you have got? 50 degrees or 50 grams of mass at 20 degrees Celsius they are given. 50 grams of water 3 degrees Celsius they are given. Temperature of mixture they are given as what is that? 75 degrees Celsius. 75 degrees Celsius. So T is equal to M1 T1 plus M2 T2 by M1 plus M2 temperature of mixture formula. So when you substitute these values, what is the value you get? T is equal to 130 degrees Celsius. Understood? See the next question. Ion of weight. So ion of weight. Weight means what? Mass. How much they have given? 2 kg. 2 kg is supplied with Q. Q value how much they have given? 12,000 12,000 calories. Initial temperature T1, how much they have given? 20 degrees Celsius. Specific heat S value 0.1 calorie per gram degree Celsius. Okay, what is the final temperature T2? Yes. So Q, M, T as all they are. What is the formula you will be using here? We will be using Q is equals to MS delta T. Okay. So here, what is the mass? Q value they have given 12,000. Okay. If you observe, it is all on calories and grams. Grams means what? Here already one value they have given in kg. So what you will do? You will convert it into grams. 1000 grams. Okay. So here mass is how much? 2000 into what is the specific heat they have given? 0.1 means what? 1 by 10. Change in temperature T2 minus T1. T2 minus T1 is how much? 20. Okay. Now 0 and 0 gets cancelled. What is the behind? 12,000 is equal to 200 into T2 minus 20. Okay. You bring this 200 to the left side. What do you write? T2 minus 20. T2 minus 20 is equals to 12,000. So 12,000 by 200. 0 gets cancelled. 60. Therefore T2 is equals to 60 plus 20. 80 degree Celsius. Understood? So what they have given? Mass they have the mass of iron they have given 12 kg. Heat they have given 12,000. T1 value they have given 20 degrees Celsius. Specific is 0.1. Since all are in calories and centigrade, what we will be doing? We will be converting this kg into grams. So T2 kg means 1 kg is 1000 grams. 280,000 is 2000 grams. So here Q, what is the formula for heat? Q is equals to MS delta T. When you substitute the value, you get 80 degrees Celsius. Understand? See the question. How much energy is transferred when 1 gram of boiling water at 100 degrees Celsius condensed to? So 1 gram of water. 1 gram of water of boiling point 100 degrees Celsius condensed to water, condensed to water at 100 degrees Celsius. So here what they are saying, simply they are saying that one person is in steam and we want to convert that steam into water. That is 100 degrees Celsius, 100 degrees Celsius they have given. So what is the question they are asking? How much amount of heat energy is required to convert its state from what? From steam to water. Changing state means what? What is the concept we will be using? Latent heat of vaporization. Steam to water. So latent heat of vaporization formula is what? L is equal to Q by M. Q is equal to L into M. Therefore Q is equal to what is this steam? Latent heat of vaporization for water. It is how much? 540 calories per gram. Latent heat of vaporization for water. So here 540 into what is the mass they have given? 1 they have given. Therefore Q is equal to how much? 540 calories. Understood? That's simple question. See the question. Three objects A at 30 degrees Celsius, B at 303 Kelvin, C at 420 K are in thermal contact. This is the condition here. Means what? All the three objects are in thermal contact. Okay, A, B and C. What is the question they have asked? What are in thermal equilibrium among A, B and C? In this A, B and C, which are in thermal equilibrium. Thermal equilibrium is what? Thermal equilibrium means what? The condition where there is no change in the temperature. Both objects should have same temperature. So if you observe here, two values are in Kelvin, one value is in Celsius. So what we will do? Temperature we will convert in temperature in Kelvin is equals to what is that? 273 plus temperature in degrees Celsius. So what is here? 273 plus what is the value given? 30. So what do you get? 3, 10, 3. So what is that? A value what we have got? A value is 303 Kelvin. If we observe this, all these values, A value what we got? 303 Kelvin. B value is 303 Kelvin. C value is 420 Kelvin. So here what is the question they are asked? What are in thermal equipment? Thermal equipment is what? Which doesn't change its temperature. So A has same temperature, B has same temperature. What we can say that A and B are in thermal equilibrium. What is the next question they ask? From which body heat will transfer? We already know that heat transfer from hotter object to colder object. From among A, B, C is what? 420. So we can say hotter object. From C, heat will be transferred to A and B. Understood? So next one. Which takes more time to rise the temperature? So they have given one values: kerosene, aluminium, water, seawater. So this is the values they have, data they have given. What they have asked? Which takes more time to rise the temperature. So here, when I am saying about the specific heat, what is the formula for specific heat? S is equals to Q by M delta T. So when I was saying this concept, I told if the specific heat of a substance is more, less change in temperature will take place. So here, what is the question they have asked? Which takes more time to rise the temperature? More time to rise the temperature means what? Temperature is not changing. Temperature is not changing is what? It doesn't want to change is what? Specific heat of a substance should be more. If temperature is changing very for less time, if they ask which takes less time means what? Very fast the temperature is changing. Here what they are asking, which takes more time. More time is what? Temperature is not changing. Which substance in which substance this condition will apply? Which substance has more specific heat? That substance takes more time to change the temperature. So here among these values, which value is greater? Water has greater specific heat. So what we can say that water takes more time to change the temperature. Understood? So here last problem. They have given one graph. So they are asking what which substance has high specific heat. Just now I said if it takes more time to change the temperature, we can say that substance has high specific heat. If you observe here, as the temperature is rising at less time, so if you observe here, as with the less time, we can observe that A substance is raising its temperature very fast. If you observe the B, it takes some more time to rise the temperature. But if you observe the C, it is taking more time to rise the temperature, very less amount of temperature. So it is taking more time to change this temperature means what? Which substance will have more specific heat? C substance will have more specific heat. With this, I have completed the numerical part. Those who have missed my previous concept. So previous concept, I have already uploaded those videos in the YouTube. You can go through it. So my recommendation is that you completely watch the video so that you can understand the complete concept. Understood? Thank you.